In this video, we'll show how to find the relative maximum and minimum of a multivariable function. First, we start by finding partial derivatives of a function, and let's do it with respect to x first. So, the derivative of the function with respect to x is simply 12 minus 3x squared. Derivative of this function with respect to y is simply negative 8y. Now we differentiate each of the partial derivatives again with respect to x and with respect to y to find the second partial derivatives, and derivative of a function with respect to x twice will be equal to negative 6x. Derivative of the function with respect to x and then y is 0. Derivative of second derivative with respect to y then x is 0. Now we can verify that mixed derivatives are the same, and differentiating the function with respect to y twice will give us negative 8. Now we look for the critical points by solving system of equations. We basically set each partial derivative of a function equal to 0. So the second equation gives us y equals 0, and the first equation gives us x squared equals 4, which has two solutions, 2 or negative 2. That means we have two solutions, 2, 0 and negative 2, 0. That means we have two critical points. Now for each critical point we will compute the value d. So d is the following expression. In our case it will be negative 6x times negative 8 minus 0, so it's 48x. That's what it is in general. And when the point is 2, 0, d will be equal to 96, which is positive. And when the point is negative 2, 0, d will be equal to negative 96, which is negative. So how do we classify each critical point? Well, it depends on d. In case when d is positive, we use the second derivative test. So for 2, 0, d is positive. That means we look at the second derivative with respect to x. It is negative 6x. And negative 6x evaluated at 2 will give us a negative value. That means the point 2, 0 is a relative max. However, the point negative 2, 0 has the d value negative. That means it's a saddle point. So this is how we find relative maximum or minimum if they exist, and the saddle point if it exists.